Russia, July 2026. Three fireballs lit up the Russian night in the span of minutes. Not in the same city, not even the same region. Three separate targets, hundreds of kilometers apart, all struck in a single coordinated operation that Russian air defenses had no answer for. This is how Ukraine did it. The operation unfolded on the night of July 14th, into the early hours of July 15th. By the time Russian emergency services reached the first blaze, the second strike was already inbound. By the time state media acknowledged anything had happened, the airfield was already burning. UNITED24 Media confirmed all three strikes with post-strike imagery. What that imagery showed was remarkable. Two major oil refinery complexes and a military airfield, all struck within the same operational window. Ukraine had not simply launched drones at a single soft target. It had executed a tri-target package, coordinated across geography and time, against hardened and defended Russian infrastructure. Nothing like this had been attempted with this precision in a single overnight window in this war. To understand what that means, you need to understand what these targets were, why they mattered, and just how difficult it is to hit three geographically separated facilities simultaneously, without any one strike alerting the defenses protecting the others. That is what this breakdown is about. Start with the targets. Russia's oil refining infrastructure is not incidental to its war effort. It is foundational. The Russian military burns enormous quantities of refined petroleum products every day: aviation fuel for its fixed-wing aircraft and helicopter fleets, diesel for armored vehicle columns and logistics trucks, and jet-grade kerosene for the missiles and drones it continues launching into Ukrainian cities. The two refineries struck on the night of July 14 were not random industrial facilities. Both had previously appeared on Ukrainian target priority assessments circulated in open-source defense analysis. Both served as significant regional suppliers of aviation fuel and diesel to Russian military logistics networks feeding the front. Russian oil refineries are not small, easy-to-miss installations. A major refinery is an enormous industrial complex. Dozens of processing units, storage tanks holding tens of thousands of tons of fuel, pipeline networks connecting to rail loading terminals, pump stations and heat exchangers, and distillation towers that take months to repair, even when replacement parts are available. Rupture the storage tanks and the fuel burns, crater the processing units and they go offline. And when the refinery is supplying fuel to a front line more than 1,000 kilometers away, the disruption compounds through the logistics chain almost immediately. The airfield strike added a dimension the refineries alone could not achieve. Hitting oil infrastructure is valuable, but it carries a residual risk. Once Russian commanders know a strike is underway, they can scramble reconnaissance aircraft or armed drones to search for launch areas, or position intercept assets to catch follow-on strikes. The airfield targeted in this operation appears to have been selected to close that window, striking it in the same operational time frame as the refineries. Some assessments suggest within minutes of the refinery hits, degraded Russia's ability to mount an aviation response during the most vulnerable phase of the operation. Whether the airfield strike achieved runway denial or hit only infrastructure and support facilities remains in the assessed category, but the strategic logic is hard to dispute. Ground the aircraft, then burn the fuel, in that order, or simultaneously. The detail that stood out most when going through available reporting: the three targets are not clustered. They are geographically separated, in different regions, at different distances, from Ukrainian-controlled territory, each defended by its own local air defense network. To hit all three on the same night with long-range drones requires something most people underestimate: the ability to time three separate strike packages so precisely that none of them triggers an early warning cascade that benefits the other defended sites. If the first refinery goes up 2 hours before the second package arrives, Russian radar operators have 2 hours to reposition mobile air defense assets, heighten alert states across the region, and activate additional intercept layers along projected corridors. The value of simultaneous timing is that it collapses Russian decision space to near zero. How was this operation built, and how were these targets found? Developing a strike target in modern warfare is not a single moment of discovery. It is a process taking weeks, sometimes months, drawing on multiple intelligence streams at once. For industrial facilities like oil refineries, initial identification is not difficult. Refineries appear on commercial satellite imagery and open-source maps. What is difficult is understanding the current operational status of the facility, the current defense posture around it, viable route options that avoid the densest air defense coverage, and the optimal timing window for a strike. All of that requires sustained collection. Ukraine's target development apparatus for deep strikes has evolved significantly over the course of the war. It draws on satellite imagery from commercial providers. Planet Labs and Maxar imagery has been cited in connection with multiple Ukrainian targeting cycles. It draws on signals intelligence, intercepts of Russian logistics communications that allow analysts to assess which facilities are actively supplying which frontline formations. It draws on human intelligence networks operating inside Russia, though the details of those networks are not publicly confirmed for obvious reasons. And it draws on open-source intelligence, the large volume of publicly available information about Russian industrial and military infrastructure that Ukrainian and allied OSINT communities have systematically cataloged since 2022. For a target like an oil refinery, analysts would be tracking railcar movements on satellite imagery, the frequency of tanker train departures, which indicates active production and delivery to military consumers. They would be looking at thermal signatures, which reveal operational processing units even through cloud cover. They would be correlating that data with known Russian logistics hubs downstream of the refinery, confirming the supply chain connection to frontline forces. And they would be tracking air defense deployments in the area, noting which systems are present, where their radar coverage overlaps, and where the gaps are. The hunt is patient, it is methodical, and it runs in parallel with the planning for the approach. The question this operation actually raises: how do you fly long-range strike drones more than 1,000 kilometers through Russian airspace, past multiple overlapping air defense belts, against 3 separate targets, without any of the 3 inbound packages being detected early enough to warn the other sites? The answer almost certainly involves several techniques working together. Route selection is the first layer. Ukraine's strike drone operators, and the intelligence and planning teams behind them, have spent years building a detailed picture of Russian air defense radar coverage across the country. The S-300 and S-400 long-range systems provide wide area coverage, but they have minimum engagement altitudes and do not cover every low-altitude approach corridor equally. Pantsir's short-range systems fill some of those gaps, but not all of them, and not continuously. Between the radar coverage of fixed-site systems, there are corridors, narrow bands of airspace where a low-flying drone, navigating at treetop altitude and following terrain contours, can pass without being acquired by ground radar. Ukrainian mission planners have become expert at mapping those corridors and routing strike packages through them. The second layer is profile. Ukraine's long-range strike drones, the Shahed derivative systems developed domestically, and more sophisticated platforms whose specifications remain officially undisclosed, are designed to fly low and slow, low enough to exploit terrain masking, slow enough to have a tiny radar cross-section at oblique angles. The combination makes them genuinely difficult to detect at extended range, particularly when navigating through areas where Russian radar coverage is sparse or pointed the wrong way. There is something about the timing of this operation that is worth sitting with. Project the likely launch areas on a map, and you see that the flight corridors to 3 targets in different directions require 3 separate packages, potentially launched from different points or at different times with different route lengths. Getting 3 drone packages to arrive at 3 separated targets within the same short window is not a simple scheduling problem. It requires precise knowledge of each drone's flight time on each specific route, accounting for wind at altitude, potential detour legs to avoid known radar coverage, and sequencing arrivals so that none of them triggers an alert that cascades to the others. The planning cycle for something like this is measured in weeks, not days. One obstacle the planners had to solve: the routes to the 3 targets almost certainly pass through areas where Russia has deployed mobile Pantsir systems specifically to counter the drone threat. These short-range air defense systems are effective against the drone profiles Ukraine uses, when they are online and oriented correctly. The reported approach almost certainly exploited a combination of timing and saturation, launching enough drones on enough vectors that mobile systems could not cover all approach angles simultaneously. When a Pantsir battery is tracking one incoming contact to the west, it is not looking east. Route planners would have used that geometry deliberately, sequencing approach vectors to force the defense into impossible choices. But there was more to it than that. One detail from post-strike analysis of similar Ukrainian deep strike operations: Russian air defense radar systems along the strike corridors were operating at reduced capacity in the hours before impact. Whether this reflects deliberate electronic interference, sensor degradation from prior operations, or the chronic maintenance problems that have plagued Russian military equipment throughout this war is impossible to confirm from open sources. What is confirmed is that 3 drone packages reached 3 separate targets without being intercepted. Whatever combination of factors enabled that, the result speaks for itself. The refineries went up first. Then came the detail that changed the character of the whole operation. The Airfield strike was not a bonus target, it was the keystone of the design. Walk through the strike itself. The first refinery complex was struck in the early hours of July 15th. Post-strike imagery confirmed multiple points of impact across the facility, with visible fire damage to storage and processing infrastructure. The fires were large enough to appear in satellite imagery taken hours later. Refineries burn hot and long. The fuel stored on site becomes the accelerant for its own destruction once the initial strike ruptures containment. The second refinery was struck within the same operational window. The exact time separation between the 2 refinery strikes is not confirmed in open-source reporting, but the operational logic strongly suggests they were designed to arrive simultaneously, or within minutes of each other, to prevent Russian air defense controllers from repositioning assets between sites. Post-strike imagery for the second facility also confirmed impact and fire damage consistent with a successful strike on processing and storage infrastructure. Then the Airfield. The Airfield strike executed in the same window targeted Russian military aviation infrastructure. The specific damage profile, whether runways were cratered, hangars destroyed, parked aircraft damaged, or fuel and maintenance facilities struck, remains in the assessed category based on available reporting. What UNITED24 Media confirmed is that the Airfield was struck and that post-strike imagery showed damage consistent with a successful operation. The significance of the Airfield strike is not primarily about the physical damage to that single installation. It is about what the strike prevented. A Russian airbase responding to a strike on its own infrastructure cannot simultaneously launch reconnaissance sorties to track outbound Ukrainian drones or vector intercept assets toward incoming packages. Put yourself in the position of a Russian air defense commander on the night of July 14th. Your radar network begins picking up contacts. Low, slow, following terrain. You have mobile assets you can reposition. You have a sector radar you can task. Then the first refinery goes up, and suddenly you have a major industrial fire to report up the chain of command, emergency response to coordinate, and a political crisis to manage, all while trying to figure out whether the drones that just hit the refinery are the only ones inbound, or the first wave of something larger. Within the same window, a second refinery and an airfield are struck. Your decision cycle has been collapsed to the point where there are no good choices left. By the time you understand the shape of the operation, it is already over. That is not an accident, it is the design. Most people assume Ukraine's long-range strike campaign is opportunistic, grab targets of opportunity, launch when conditions are favorable, hope some get through. The evidence tells a different story. What this operation demonstrates is a systematic, methodical targeting process that identifies complementary objectives, designs approach corridors that exploit specific gaps in Russian air defense coverage, sequences arrivals to prevent cross-queuing between defended sites, and executes against all 3 targets simultaneously to prevent adaptive response. This is not improvised. This is a mature deep strike planning capability. The 3 targets burned. Then came the question the Russian military could not avoid. What was actually lost? The damage assessment is where confirmed and claimed diverge, and it is worth being precise about what is known versus assessed. UNITED24 Media confirmed all 3 strikes with post-strike imagery. That confirmation covers the fact of impact and the presence of fire damage at all 3 facilities. What remains assessed is the precise scale of capability loss at each site. How many processing units were destroyed versus damaged, whether storage tank farms were fully compromised, whether the airfield sustained runway denial or infrastructure damage, and how long each facility will take to return to operational status. That caveat matters, but it does not change the strategic calculation significantly. Russian oil refining capacity is not infinite, and it has been under sustained pressure since Ukraine began its deep strike campaign targeting fuel infrastructure. Each successful refinery strike forces Russia to make choices: divert product from civilian consumption to military requirements, draw down strategic reserves, reroute supply through alternative facilities that then become bottlenecks, or accept reduced availability at the front. Any one of those options has costs. In combination, they add up to a logistics problem that compounds over time. The refinery sector has also proven difficult for Russia to defend adequately. The facilities are large, fixed, and their locations are publicly known. Defending them against long-range drone strikes requires either enough short-range air defense coverage to saturate all approach corridors, which Russia does not have in sufficient quantity, or the ability to intercept drones at extended range before they reach the target area, which requires knowing the exact approach corridor in advance. Ukraine's route variation and simultaneous multi-target operations specifically defeat that approach. Here is a take that will probably generate pushback. The refinery campaign is arguably the most strategically effective element of Ukraine's deep strike program, more so than the strikes on Russian command posts or ammunition depots that generate more media coverage. Fuel is the one input the Russian military cannot substitute or improvise. It cannot fight without it, it cannot fly without it. Every barrel of refined product that burns in a Ukrainian strike is a barrel that does not reach a Russian armored column, an airfield, or a missile battery. The logistics math is unforgiving. What about the airfield? Suppression of Russian aviation response during the strike window is a significant operational achievement, but the longer-term consequence depends on what specifically was hit and how long repairs take. If the strike cratered runways, the grounding effect lasts days to weeks. If it hit fuel storage, maintenance facilities, or parked aircraft, the effect is longer lasting and harder to reverse. The honest answer based on available reporting is that we do not yet know. What we do know, 3 targets were hit. Russian air defense did not intercept the strike packages despite having radar coverage in the regions involved, and Ukraine successfully executed a simultaneous multi-target operation against geographically separated defended sites within a single overnight window. For an operation of this coordination complexity, that outcome is a strategic signal independent of the specific damage numbers. Now for the open question the damage assessment actually raises. How does Russia respond? The refinery burns, the airfield smokes. Somewhere in a Russian government office, someone has to answer a question with no good answer. Russian responses to Ukraine's deep strike campaign have followed a pattern. Public denial or minimization, followed eventually by acknowledgement of infrastructure damage framed as Ukrainian terrorism. Additional air defense assets repositioned to the most recently struck regions, which then creates gaps elsewhere. Accelerated maintenance cycles on surviving refinery capacity to compensate for lost output, which puts additional strain on equipment and workforce. And periodically, retaliatory strikes on Ukrainian infrastructure that are operationally unrelated to the Ukrainian strikes but politically necessary for domestic consumption. None of those responses solve the underlying problem. The underlying problem is that Ukraine has demonstrated the ability to plan and execute multi-target simultaneous deep strike operations against fixed infrastructure at range. That capability does not go away because Russia repositions a Pantsir battery. The planning cycle that produced the July 14th operation is already running its next iteration. The target development process for the next strike package is already underway. The route analysis for the next set of approach corridors is being refined. And Russia's fixed infrastructure, its refineries, its airfields, its logistics nodes, cannot be moved. What this operation signals about what comes next matters. The simultaneous tri-target package is a template. It demonstrates that Ukraine's strike planning apparatus can coordinate multi-axis simultaneous operations against complementary target sets, infrastructure that feeds the front, and aviation assets that could respond to protect it. The next evolution of this template might involve 4 targets, or 5, or might substitute a different combination of target types. It might incorporate sea drones against coastal logistics infrastructure in the same window as inland refinery strikes. The specific combination will be driven by target availability and desired operational effect. But the planning and coordination capability that produced the July 14 operation has been demonstrated and validated. Looking back at this operation, the real question is not what did Ukraine strike? It is what Russia cannot protect. The answer, demonstrated on the night of July 14th, is more than it can defend simultaneously. That gap between what needs defending and what can actually be defended is the opening that Ukraine's deep strike campaign is designed to exploit. Each successful multi-target operation widens that gap, because each one forces Russia to spread its already strained air defense resources thinner, while Ukraine's strike planning apparatus accumulates experience and refines techniques that make the next operation more effective. One number kept coming back when going through the post-strike imagery and reporting. The July 14 strikes were not Ukraine's first against Russian oil refining infrastructure. They were part of an ongoing campaign that has now struck dozens of refinery and fuel storage sites across Russia over the course of the war. The cumulative effect of that campaign is measured not just in individual fires, but in the sustained reduction in Russia's ability to supply its front with the fuel needed to sustain offensive operations. This single operation, viewed in isolation, is significant. Viewed as part of a campaign, it is a chapter in a much longer and far more consequential story. Will Russia find a way to adequately defend its refinery network against Ukraine's evolving strike capability? Leave your assessment in the comments, yes or no. The engineering answer and the military answer are very different things, and the gap between them is exactly where this campaign lives. The fires from the night of July 14 have been extinguished. The damage assessment teams have done their work. The post-strike imagery is in the archives, but the operation's consequences are still unfolding. In the Russian logistics system, in the fuel availability calculations at Russian frontline units, in the air defense repositioning decisions being made in Moscow, and in the targeting cycle already building the next strike package. 3 targets, 1 night. Hundreds of kilometers of Russian airspace navigated without a single interception. The tri-target simultaneous operation is no longer a concept or an aspiration. It is a proven capability. And the question Russia cannot answer is not whether Ukraine will do this again. It is where the next one will hit. If you want a deep breakdown of Ukraine's sea drone campaign against Russian Black Sea logistics, how Ukraine built that capability, how it has evolved, and what it has actually destroyed, that breakdown is already on this channel. The connection between the sea campaign and the land-based deep strike program is closer than it looks, and understanding one helps explain the other. If this breakdown gave you something you did not know before, subscribe. Every operation in this war has a story behind the headline. This channel exists to tell it.